this lesson, you'll learn how to identify the domain of application problems. Let's look at example 1. Mason stands on the 5th step of a vertical ladder. The ladder has 15 steps, and the height difference between consecutive steps is 0.5 meters. The function h of n models the height above the ground of Mason's feet in meters after moving n steps. If Mason went down the ladder, n would be negative. So our question is asking us, what is the appropriate domain? Remember, domain stands for your x values or your input values. So let's determine what our variables represent in this problem. We have h of n that models the height above the ground. And that is the height above the ground of Mason's feet. Then we have n is the number of steps. So because n is our input number, that will be the domain that we're trying to determine. The number of steps, what values would be appropriate for that domain. So now we need to gather some important information. You can reread the problem for a second time, or just go and try and highlight areas that you feel are important. We know that Mason stands on the 5th step. The ladder has 15 steps. We know the height between each step is 0.5 meters. So pulling out that important information. It's also good to know that if he went down the ladder, our n will be negative. So jot down that important information so we can decide of that information that's provided what will be used to calculate the appropriate domain. And that is step 3. We're going to calculate an appropriate domain from the information that you have found in the problem. Well, if he starts on step 5, remember n is the number of steps. So if he's starting on step 5, that's going to represent n being 0 because that's his starting place. If he moves up the ladder, that will increase our n value to 1, 2, 3, 4, all the way until he gets to the top of the ladder. Because the ladder has 15 steps, our maximum n value will be 10. If he's already on step 5, to get to the top, there's 10 more steps, so that's as far as our n value can be. Remember that it said that if he goes down the ladder, our n will be negative. So the first step he takes down will be -1. Since there's a total of 15 steps, he can go down those 5 steps where he started at the 5th step. He'd go down 5. So that would be represented as n equals -5. That is our minimum value of our domain. So now we're going to select the best answer choice. Option 1 is from 0 to 15. That would not make sense because at 0, that is where Mason is standing. There were steps below that, so we would need to include those as well. So also we can eliminate the next option because 0 again is where he's starting. He would need to move down the step and include those as well. The next option, -2.5. We would not want to pick this option because there were more than 2.5 steps below where he was starting. That's why the last answer choice makes the best sense. It shows from -5 all the way to +10 as we discussed here. Our starting step is that 0, which is included between -5 and 10. Our maximum value, if he went to the top of the ladder, it would be 10 steps. And our minimum value is that -5, so that's represented here in that notation. Let's look at example 2. Officials in a town use a function c to analyze traffic patterns. The function c of n represents the rate of traffic through an intersection where n is the number of observed vehicles in a specified time interval. What would be the most appropriate domain for the function? Well, we're told about the value c, and that's the function that analyzes the traffic patterns. So c of n represents that rate of traffic through the intersection. N is the number of observed vehicles in that specific time. So n is our domain, that's our input value. So think about what domain values, what would be an appropriate domain value, what would be appropriate n values for the number of observed vehicles. Let's look at the first option. If we have -2 vehicles observed, that's not even possible. A negative number of cars is not possible. So we can eliminate that answer because cannot have negative observations. So therefore the next one's also eliminated because again you cannot have, if our n represents our input, that's our domain that we're looking for. If that's the number of observed vehicles, again we cannot have this negative value. Let's look at the next option. Think about each value. We could observe no vehicles. We could observe these positive values 1, 2, and 3, and this means it continues on to infinity. So this would be an acceptable answer, but let's look at the last one as well. Starting at 0, that could occur, having no observed vehicles, but 0.5 does not make sense. You could not observe half a vehicle. So this one we can eliminate because the number of observed cars cannot be half values. So therefore, the third option makes the best sense for choosing an appropriate domain. The number of observed vehicles could be from 0 to all the positive values, 1, 2, 3, and onward. Let's look at example 3. The soccer team is selling candy bars to help pay for their uniforms. Each player's uniform costs $40. The function f of c represents the amount of money raised when the soccer team sells C candy bars. What is an appropriate domain for the function? Right off, you should get familiar with what the problem is talking about for the variables. It told us that f of c represents the amount of money raised, and c represents the candy bars. So right away, identify which one are your input values or your domain values, and that would be the c. C for the candy bars is your domain or your input. We're going to be writing an appropriate domain for that function. The next thing we need to do is gather the important information to be able to find the domain. We're told that they're selling candy bars and $40 per uniform is not needed for the domain. So the things we need to know is pretty much that the soccer team is selling some candy bars Yes, they're going to help pay for their uniforms, but because C is our input value, we really only care about the fact that they are selling some candy bars. In order to help us define that domain, the amount that they'll have to pay for the uniforms is not helpful. So to be able to calculate an appropriate domain from that information, think about that the team will want to sell as many candy bars as possible. If the team sells no candy bars, they will not earn a profit, but 0 can still be included as part of the domain. The team cannot sell a negative amount of candy bars. So we're going to say that the candy bars, it could equal 0. Also, the candy bars will not be negative values. It would only be positive. So think about how you could write that as a domain. We could do it as set notation, so that would be the set of all C values such that C would be greater than, because we said no negatives, so we're wanting greater than, and we do want positive values, but it could also even be equal to 0. That would include only positives. It would exclude negative values, but you could sell 0 candy bars, although that would not help them purchase their uniforms. It still could happen, so we want to consider that as part of the domain. To write that in interval notation, so one answer or the other, you don't have to provide both. This would be set notation. To do interval notation, we could say that it be from 0 to infinity. We would use brackets on 0 because we want to include that. We want to show that 0 is included, and then infinity would never be included because it's not an actual number. So that's how we could write our domain for this problem.